Yeah. Good morning, students. So here I want to explain about the acidic nature of alcohols, carboxylic acids, and basic nature of amines. Uh, so in IBM section and in main section, I didn't discuss about this topic in a general organic chemistry. So today you study general organic chemistry. So you must study about the acidic nature, basic nature. So whatever I am going to discuss, that also includes in a examination. Okay. So first of all, here they also includes so many different type of topics. So mostly here that is started with electronic effects. Among the electronic effects here, inductive effect, resonance effect or mesomeric effect, hyperconjugation. So in this explanation of acidic nature and basic nature, so here just I want to discuss about this topic, which involves only inductive effect. So you know that inductive effect is a movement of the sigma bonding electrons towards more electronegative atom. So as a result here, the one group carries a negative charge and other group carries a positive charge, and this inductive effect is divided into two types, so plus I effect and minus I effect. So generally here the less electronegative atoms are acting as a plus I groups and alkyl groups are acting as a plus I groups, and the groups which have the more electron density are acting as a plus I groups. Here plus I group means here electron donating groups, and the plus I groups release the electron density towards other group. And now your minus I effect, that means here in a molecule the group or the atom which accept the electrons towards itself is known as a minus I group, or that phenomenon is known as a minus I effect. So generally most electronegative elements or most electronegative groups or the group that group a particular atom has a positive charge are acting as a minus I group. So because here these are very electron deficient, so accept the electrons, that means here minus I effect. So it is a minus I effect of the different groups, and here it is a plus I effect of the different groups. So this was discussed in a classroom. Now here, so I'm going to start acidic nature of alcohols. Now here generally acid means here the proton donor is the acid. So now here this alcohol donate one proton, and that produce that is converted into alkoxide ion. This is generally we know that this is alkoxide ion. Now here in acidic nature of alcohol, here the different type of alcohols are there. So which alcohol is a stronger acid, which alcohol is a weaker acid, that we have to decide. Now here, so that means here one is a stronger acid, one is a weaker acid. So generally here if any compound produce more concentration of H plus ions, that is said to be stronger acid. So here strong acid has a higher tendency to release H plus ions. So higher the concentration of H plus ions, higher the acidic nature. That compound, that alcohol is said to be strong acid. Now for suppose here this acid alcohol is dissociated into alkoxide ion, that is the conjugate base, and produce H plus ions. Now this reaction, that means here Ka, acid dissociation constant. So generally you might have studied in equilibrium, that means chemical and ionic equilibrium topic. So Ka is the acid dissociation constant. Now here Ka is defined as like this here. It is a ratio between the concentration of the product, concentration of the H plus, and that means and concentration of the reactant. So here, so higher the concentration of the H plus, so higher the acidic nature. Generally, you are saying that means here higher the H plus, so higher the Ka value. So higher Ka value, stronger acid. That means next year pK value, it is a negative logarithm of the Ka value. That means here higher the Ka value, so lower the pK value. So higher the Ka value, stronger acid, lower pK value, stronger acid. So now here higher Ka, stronger acid, higher pKa, it means a weaker acid because it is a negative logarithm of the Ka value. So of course you studied in equilibrium topic this one. Now acidic nature depends on stability of the RO minus. because here if any compound produce more number of H plus ions, it means here that alkoxide must be more stable. If it is a more stable, this compound can produce a more number of H plus ions. So here acidic nature depends on the stability of this conjugate base that is formed after dissociation of this OH1. So higher the stability of conjugate base, higher the acidic nature. So if it is a more stable, the rate of forward reaction is more. The rate of forward reaction is more means here that produce a more number of H plus ions. So here finally I am saying this acidic nature of any compound, not only alcohol, carboxylic acids or any compounds, phenols, acidic nature depends on the stability of the conjugate base. So in case of alcohol, conjugate base is a alkoxide ion. Now here this alkoxide ion is a anion. So generally here anions are stabilized by the minus I effect. This minus I effect means here these minus I groups are the electron withdrawing groups. So these electron withdrawing groups withdraw electron density. So here the magnitude of the negative charge decreases. So it is stabilized by the minus I effect. So more minus I effect, strong acidic compound. So now here one example. CF3CH2OH, CH3CH2OH. So between these two compounds here, we have to tell which is a more acidic compound. Now here, this is the alkoxide ion after loss of proton. For this compound, it is alkoxide ion. So between these two compounds, which conjugate base is more stable? Which alkoxide ion is more stable? So generally here, the CF3, the electron withdrawing group. So as a result of this electron withdrawing nature, this that means this oxygen has less magnitude of negative charge, because here this negative charge is pulled by the CF3 group. Actually it is electron withdrawing group. So here the magnitude of the negative charge is dispersed. That means here there is a dispersal of the negative charge by this electron withdrawing group. So here this anion has a less magnitude of the negative charge, so it is a more stable. So generally ions which have less magnitude of the charge are more stable. So here this negative charge is dispersed by this electron withdrawing group. So this conjugate base is more stable. But here in this case, this ethyl group totally electron donating group. So it is not stabilized by this electron donating groups. But here anions are stabilized by the electron withdrawing groups. So this conjugate base is more stable. It is readily donates proton. That means here the it prone to release the H plus ions. So here it has a less tendency to release H plus ions, because here formed conjugate base is less stable. But in this case here formed conjugate base is more stable, that has a higher tendency to release H plus ions. So here between these two compounds, this compound is a more acidic compound. So finally I want to say, if any compound having electron withdrawing group is more acidic in nature. Or suppose here coming to this example, this one has a fluorine and chlorine, bromine and iodine. The minus I effect of these compounds here, fluorine greater than, chlorine greater than, bromine greater than I. So higher the minus effect, more acidic nature. The very simple to identify the strong acidic compound. So higher the minus I effect, higher the acidic nature. So first of all, you have to find out the compound which has a strong minus I group. So that is a more acidic. The compound which has a plus I group, that is a less acidic. Now coming to next one. So here NO2, 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 NO2. That means here the same minus I group, but here the minus I group place is different. This minus I group is very close to the OH. This minus I group, here the place of the NO2 group increases from OH, from compound to compound. That means here with increasing distance, actually inductive effect decreases. So this NO2 is very close to this OH group. That minus I effect of this NO2 is working more on this OH group. So here in this case here that NO2 is at the terminal. So that minus I effect of this NO2 is working very less on this oxygen. So it is a very weaker acid, it is a stronger acid. So A, B, C, D. So generally you are saying inductive effect is a distance dependent. So next here another example. So we said that any alcohol with minus I group is more acidic. Now here, this is a methyl, this is ethyl, this is a propyl. So generally here methyl, ethyl and propyl are the plus side groups. So with plus side effect increasing, the acidic nature decreases. So that's why methyl alcohol is more acidic than the ethyl alcohol, and ethyl alcohol is more acidic than the propyl alcohol. Now this is the ethyl alcohol, isopropyl alcohol, tertiary butyl alcohol. This ethyl group, isopropyl group and tertiary butyl group. Tertiary butyl group is a strong plus side group, so it is a less acidic in nature because the plus side group cannot stabilize the anion, that is a conjugate base. Now here this ethyl alcohol, this is thioalcohol. Between these two, which is a more acidic. So generally this acidic nature is explained on the basis of the bond dissociation energy. This bond is a very weaker bond. So here due to this bond is a weaker bond, it readily dissociates and release H plus ions. So here SH bond is a weaker bond than the OH bond. It is a higher tendency to release H plus. That's why thiols are more acidic than the simple alcohol. So next here another one, H of H2O, acetylene, ammonia, ethylene and ethane. It is acidic nature order. So of course it is explained on the basis of the stability of the conjugate base. F minus more stable because here fluorine is a more electronegative element, so that can bear the negative charge. And next here oxygen, and now here generally carbon, nitrogen. Between these two generally nitrogen is more acidic, but here this is a sp carbon. Sp carbon is more electronegative because here with increasing percentage of the s character, so electronegativity increases. So sp carbon is more electronegative, so that more electronegative atom can bear the negative charge. That means negative charge is more stable on the more electronegative atom. And next nitrogen and sp2 carbon, sp3 carbon. So here based on this conjugate base stability, we wrote this acidic nature order. Now here, and water and alcohol. Between water and alcohol, your water is slightly more acidic when compared to alcohol. So because here this hydrogen inductive effect is 0 and this R means here it is a plus side group. So by presence of the plus side group, acidic nature decreases. Okay, alcohol is more acidic than the water. Now here this is a phenol and this is the alcohol, this is the aliphatic compound. Now between these two here phenols are more acidic. That means here finally we can give one statement, the phenols are more acidic than the alcohols. So because here the conjugate base of phenol is a phenoxyl ion. So you know that resonance, so it is stabilized by the resonance. So this conjugate base is more stable when compared to this RO minus. For this conjugate base here there is no resonance working, but in this case there is a resonance, so it is stabilized by the resonance. That's why phenols are more acidic than alcohols.